Good afternoon, everyone, and welcome to this week's episode of MSME Masterclass. Today, we are focusing on a topic that directly impacts profitability and operational efficiency for small and medium manufacturers, which is reducing material waste in steel fabrication units. We are privileged to have with us Mr. Manish Bansal, Managing Director at Aayas Global LLC, a seasoned industry leader with over 30 years of experience across stainless steel manufacturing, metal recycling, and ship recycling. Mr. Bansal has spent decades solving real-world challenges in heavy industry, especially around material handling, alloy selection, and maximizing yields from iron ore, every ton of steel. His insights today will incredibly be valuable for MSMEs involved in fabrication, industrial components, and metal processing, particularly those looking to bring down costs without compromising on the quality. Get ready to explore practical ways to control scrap, optimize raw material usage, and build a more efficient and profitable fabrication workflow. Please join me in welcoming Mr. Manish Bansal to the MSME Masterclass. Welcome, sir.
Hello, thank you for a very brief introduction. Yeah, delighted to be a part of your episode. Yes, tell me, ma'am.
Thank you, sir. So my first question to you is, we would like to begin with the basics. And if you could help our attendees understand, how would you define material waste in a typical steel fabrication setup?
Okay. See, material waste is nothing but the cutouts, machinable chips, rejects, rework places, rusted or absolute stocks, inaccurate scrap records, and material lost during handling or transport. So it is only defined in these categories.
Got it. And from your experience, what are the most common types of wastage that tend to go unnoticed on the shop floor?
The most important and the common wastages on the shop floors can be offcuts, nesting losses due to cutting, scrap from inaccurate cuts, holes, bends, rework during the rework happening due to wrong dimensioning or poor quality of the material, and rusting, storage loss, over ordering or absolute inventory, human errors, that is wrong material or wrong thickness processed, and other losses can be defined as misplanning. That is it. I think I've covered the subject according to the losses.
Okay. And why do you think, sir, steel waste doesn't often get addressed seriously in an MSME environment?
See, the steel waste often goes unnoticed in the MSME environment because there is no baseline measurement of daily scrap logging. Waste is perceived as a part of process. Focus on meeting delivery rather than yield. And MSMEs are dealing with their day-to-day, hand-to-mouth basis about productivity, manpower, management, and limited resources. More importantly, small MSMEs deal with machine upgrade problems, or maybe the machines are not up to the mark. They are using old technology, old absolute machines to cater or get the yield which compares to the latest machine of their competitors, which of course their cost of production is low. That is why they are in the market, because new machines will cost more and the overheads would be much more than what their overheads would be. That is what keeps them going. But apart from that, they overlook the thing by saying it's a part of the process, it's a process loss. So that is where it gets unnoticed.
Okay. And how much of a difference can better design and planning make in reducing scrap or offcuts?
See, the design and planning is everything to reduce with offcuts or scrap. Good design reduces the scrap, increases the number of unique parts, aligns parts with the standard plate sizes, allows nesting of similar shapes. Even planning identifies critical tolerances that impact rework. Design for manufacturing directly cut material losses. Coordination between these two helps in proper sourcing of material, no excess ordering of the raw material from the steel plants or the distributors, whatever will be their sources or traders. So that is the most important part, I believe.
So
Proper
you
coordination is important.
got it. So do you think smaller units can also benefit from techniques like nesting or smart cutting layouts?
Yes, the smaller units will definitely benefit from nesting and optimizing cutting because it will scale with the material cost and complexity. Low cost approaches, manual grouping, even simple Excel cut lists, or inexpensive nesting apps shall deliver the meaningful savings. Whereas basic apps which are available in the market very reasonable that will help in the planning and optimizing their productivity and reduce their overall cost of scrap. And what we do over here is that we do it manually also. We have a system in place also, and we keep tracks on both the ends in case the the online thing is wrongly entered. We can catch it with manually entered stuff, and this helps in the traceability. This helps in the identifying the wastages incurred due to sometimes weight loss, external weight losses where the payment is much more outside and it is lesser when we weigh inside. Then we can calibrate whether it's gone wrong, whether transporter has done something, or whether there is some genuine fault of some weigh bridge or some the weighment system at our end. This is the one important aspect which has to be taken into account for which can at least save 1% of your loss, which goes unseen.
And so, how important is raw material traceability when we're trying to cut down on overuse or repeat orders?
Yeah. See, raw material traceability or batch-wise traceability, what the any corporates, any large companies, or any vendor wants or is expecting from any MSME who provides processing work or component supply of raw material to component manufacturers like what we do. First of all, it it maintains your system where they are sure that whatever batch you are using is the right raw material what they have asked for. Lot of corporates have a prescribed raw material sourcing sanctioned rolling mills or large mills like JSW and others, where they definitely say that we want the material from this rolling mill or this corporate. And in the product what we produce, if we are able to define and prove that that yes we have used this material to process the product for their components, like we are into bright bars, stainless steel, alloy steel also. So we are using batch wise tracing from right from inward where it is traced, where it is identified, and then every process the batch keeps on going ahead, and final product the same batch is then delivered, wherein the app or the traceability system in place should be in a way that you can go back to it within a matter of minutes if there is any complaint, and cater and also give them proof that see this is the batch which we have used and this is the paper log what we have tagged upon, and all at our end is complete traced.
Mm.
Now it goes to the store manager at their end where mainly we have observed that the customers don't have one supplier, they
Right.
have multiple suppliers. So then it is a part of their ball game to then identify from where the supply has come.
Correct.
So that gives reliability and that gives confidence in the suppliers or our customers that that this company has got batch wise traceability, and whatever we are telling or the premium what we are giving to them is justified. So it helps in that way. The time is everything. If the complaint comes and we don't address to the complaint within 2 hours, then the word goes out, then it is a big hassle, the market is small, and the customer has other orders which he would uh, defer to other customers, other providers. So to cut all that, we have to promptly look into the complaint part on priority basis, on urgent basis, and give them the logs. So that stops over there, and the other orders which are going to come our way does come. So I
Correct.
think it is the most important aspect in the industry where it is not a niche industry. You know,
Right.
the traceability part is because after the product is produced, there is no stamping, there is no nothing. All the heat number and everything is when the coil has arrived. We are into wire rods and making bright bars. So everything is at the coils are arrived, and we are producers of bright bars where we convert from wire rods to bright bars. So it is most important because that will give a long lasting relationship with any customer.
Got it. So, if you had to spot a few red flags, what are some signs that a fabrication unit is silently losing money on due to material inefficiencies?
See, the red flag would be higher scrap rate. As I had previously noticed and informed that visible scrap weight, that is a small percentage of input where there can be a weight difference between the external weighment and internal weighment, and all material has to be weighed on the inward process even though it is weighed from outside. That keeps a uh, account. And the second part would be frequent reworks, returns, or missed deliveries due to quality problems. So that caters to the most important part where the losing money comes from material inefficiency. The third and the most important is low inventory, which turns into a blocked or rusty stock. Since if it is a stock which deals with alloy steel, MS, pre-cutting, they tends to rust. So it is very important that the stock gets rolled on a very quick basis, wherein the cash carry inventory and the cash conversion ratio is also set for material efficiency, and also the cost on the inventory is reduced, enhancing the profitability of that unit.
Understood, sir. For units without access to expensive software, what simple methods can help them track steel usage more accurately?
See, for units who are small MSMEs, simple smartphones, Google Sheets, live entries definitely helps. Labeling on the bundles helps a lot. Keeping an inventory on the book as well as on Excel helps. But yes, you have to dedicate 1% or 2% who are onto the inventory thing where it is tracked completely, so that the wastage is calculated per lot basis, like what we do in our company also. We calculate wastage on lot basis, wherein the whole truckload has come, we are identifying the the product, we are batching the product, we are putting a tag on on the bundles, and then carrying it forward till the delivery. Of course, it is like, till that product is delivered, the weight loss or the process loss in real time wastage ratios is not achieved. But since the product is delivered, it is definitely there that yes, why has this product uh, attracted higher process losses than the normal ones? So we can go back and check whether there was some error in, or there is some rework happening on the floor which goes unnoticed to the management, because the operator will never come up and tell, sir, ye galti ho gaya, and I have done the rework.
Mm.
That is only possible if you track the batch. Otherwise, it goes and the material is dispatched, and you never know, why the weight loss has occurred to your company.
Now, so moving on, can you tell our attendees if there are any low-cost tools or systems you would recommend for real-time tracking of waste or yield?
See, the low cost systems can be achieved by proper training. You have to train your operators, you have to train your material handlers, and to log the systems rightly in the book. You can keep a manual book, you can keep a Excel, like I had told you previously. And there are also softwares available in the market which are low cost, which is don't attract a lot of cost. But I feel just logging on the book and Excel will do the job in the starting. And when the complexity starts, then the MSMEs or the processors should go in for a app or a software where they can log the software, because most important with these tools are data entry and logging. If the person is not doing the logging part, nobody can help it. The system will not operate. So I feel first manual, master the manuals, master the logging on the books, and then second step is putting the app and taking a software or something like that, because a lot of softwares are available which are not very expensive. Yes.
Okay. Can part standardization actually reduce material waste, or is it that more relevant to large factories only?
No. Uh, this is the basics. What is there in the machine floor or determining to cut waste? The products what we make are to be standardized, where a proper standard and identified cuts will give you fewer setup errors, lower inventory types, simplified procurement, and less of cuts complexity, in a way that you can mix and match the product in a way that you get a better yield. And better yield concludes to less wastage. So standardization is also important for the product, as well as the standardization is also important for the spare parts, where you're using in the used machines. You can standardize the parts, you can keep a proper cycle. I'll go one step ahead of only waste is not created because of standardization of parts. Waste is also created because of short breakdown of machines. If the machine is under the breakdown, or it is not giving a proper cut, if the tool is burnt out, the scrap increases. So standardization of that tool is important. Standardization of understanding the cycle of wear and tear is important, wherein the operator understands all this, but it has to be logged, and the manager has to be there to understand that yes, this tool or this component, a gear component or cutter component, is being using from this tenure, wherein he understood that this is his cycle run time, and overrunning the cycle time will tend to increase the weight loss or the rejections or the rework. So I think yes, standardization helps in all these parameters.
So, in sourcing steel, according to you, what are some of the common missteps that MSMEs make that lead to excess or unusable stock?
See, the common mistakes what the MSME makes is while ordering odd sizes instead of standard thickness and lengths, or instead of uh, going through the source of buying, they think that little bit discount is available, so they buy twice the material. So that creates a complexity in the consumption patterns. The order is say 10 tons, so they need to order the coils 10% in variation to 10 tons. That can be 10 tons 100 kgs or 10 tons 500 kgs, but they go ahead and order 15 tons. So that 5 tons of material which they have over orders become their dead stock or become their inventory overload on their finances. So that comes and hits the cash flow, that comes and hits uh, the blockage of funds, which gets aggregated if such blockages are multiplied on the shop floor.
Got it. Would you say better alignment between the design team and procurement can help cut material waste?
Yeah, definitely. A better alignment is everything. It is everything because the procurement team has to go back to the drawing team or the design team to get approvals if the particular size is not available with the supplier. There is multiple of times that whatever size you require to process a particular product is not available. Another size of 1 mm plus or 2 mm plus is available. So they have to go back to the design team and get approval that yes, they can procure such material. Without approvals, then it goes into basic issues of inventory multiplying and dead stocks.
Got it.
Definitely, it is most important.
Got it, sir. So is scrap always a loss, or are there ways for MSMEs to reuse or even monetize it effectively?
See, scrap is not always a loss. Scrap is the last form of value arrived from the material. Above scrap, there is a commercial grade which is available. You may be producing for an exporter or a large corporate where they give you the premium for that product. Now, since the product is not achieved that quality, which can go to the large corporate or an exporter, it can be sold in the commercial market where it can fetch a little price less than that, but more than scrap. Some rework has to be done to reach that quality, but definitely more than scrap. And then after that comes the retail buyer who would require the requirement as per his sizes. So that can also be understood and kept rather than just putting the material into scrap. And if all that options of first the order, second the commercial market, third the retail customer is exhausted, then comes the scrap, where that is the last thing you have to take it up and not multiply your inventory. So you have to remove scrap. Otherwise, it will again be a space burden. It will be a issue with the capability of storage of material. So you need to remove scrap on regular basis.
And according to you, sir, what are some useful benchmarks or KPIs that MSMEs can track regularly to monitor waste or material yield?
See, material yield is nothing but the net product weight minus the gross input weight into 100. That is a percentage. The scrap is the scrap weight minus the loss weight. And the final pass yield is the percentage of parts quality control first time. So inventory turns will be cost of goods plus average inventory. So rework hours per month or rework cost as percentage of sales Typical target ranges depend on the process. Scrap 2 to 8% is common amongst the lower over time, wherein if we achieve the scrap of 2% is a direct profit of 6%. So that is how it is to be calculated.
That was my last question to you, sir. With that, we've come to the end of today's masterclass session. Thank you so much for joining us and for being our speaker for today's session on reducing material waste in steel fabrication units. Thank you so much.
Thank you. Thank you. Nice
For
to
our
be here.
attendees, thank you, sir. For our attendees who are online, if you'd like to view the current episode, if you've missed any part of the current episode, please go on YouTube, type GS Chapter 1 MSME, and you'll find all the episodes uploaded there. Thank you once again, sir. Bye-bye.
Bye. Thank you.